Hello folks, well, back onto this. We're on the Murphy CBH1500 base station, and this may be several episodes rather than just one. So what we're doing is a lot. This is the Murphy CBH1500 that I bought from the farm. If you remember, I bought some rather dirty. There's the remains of the mains plug. There's the radio, and it would have once said Murphy there. And as we all know, the meters on these radios rarely work. So what we're going to do is we're going to replace the meter, whether it works or not. This is the demonstration. I was going to do it on a different set that I'd already taken the lids off, but can I find that set? No. And the reason I say that is because there's the front, which we removed to remove the meter. And what I did was to send these up to our friend Gareth in Leeds, and what he's done is to 3D print an adapter that enables us to fit a Maxcom type of edgewise meter instead of that, because we're seeing 9 out of 10 of these sets with meters which are duff. They were never intended to be illuminated for a start, and the illumination melts the innards. Remember, these are 40 odd years old. They were a Spirit 40F hand portable, transportable. That's one of these. I've got one handy in bits. That's a Spirit 40F. That's the innards, and you'll see in a moment when I take the lids off, it's of course exactly the same. So it's a Spirit 40F, transportable, in a big box with a power supply, and it always hum. But recently we've been changing capacitors in the power supply to stop that humming from happening, which has worked. So I'm not a design engineer, I'm a service engineer. There's a difference. But what we're going to try and do, and I haven't got really the instrumentation to do it, is to show ripple on the power supply before. We have a diagnostic oscilloscope, and I'm trying to think where it even is, because the oscilloscopes we've got on here are kind of 1 meg ones, so they're not really going to show ripple. But I'd like to show before and after. What I will say is we definitely don't have the absolute correct things. We don't have a differential probe, we don't have a differential preamplifier, which is things which you would need to do it properly. But we may be able to get a bit of a comparison of before and after. I don't know, we'll find out. I've never done that kind of thing. So we've got these adapter plates which Gareth has made, and some he's sanded and some he hasn't, and we've got a choice of them. That plate fits in like that, and our meter fits in like that, and then we have a clamp, and that should fit exactly in what was there before. And this idea was one of our other customers. If you showed me, if I showed you this, we did his radio, couldn't do anything with the meters, and he did this with sticky tape and paper and things his own way. And I did show what he'd done, and it was such a good idea. We've asked Gareth to do that for us, which he has. So we'll come back to that, and we'll get on with the actual radio. But that's the reason we're doing the radio, and the other reason being to do with the power supply, because we can actually show a before and after ripple. I'm not going to, what we're going to start off with, we're going to do the radio, we're going to service the radio. I've no reason to believe it won't be repairable. We'll service the radio as a normal radio. We'll run it on our external power supply as we normally would do, and then we'll do all the capacitors, and before we do the capacitors, we'll do a before and after on the ripple. Now we'll be changing the power supply capacitor on the radio board immediately. Oh, and I've got a doctor's appointment in 20 minutes, so that's how long we've got on this. this will give me the opportunity to take these lids off and the front and put them through the dishwasher, because these radios do work nicely, considering they're transportable in a big box. They do work nicely. They were made for Great Universal Mail Order catalogue as the only source for these products at the time. Comet bought the bankrupt stock, or the chucked out stock, and initially sold them for £69, because these have been £99 at Great Universal, and then they were ditched finally at £29.99. So we'll try and vacuum this out a bit, but I'll take this bottom off. Well, if the meter works on this, well, in that case we'll keep the meter on one side, because there's other sets I own where the meter doesn't work. This will get the Maxcom meter modification, whether it needs it or not. It's part of today's demonstration. Have I missed a screw? I haven't, you see, this is it. Sure, our dishwasher can improve on this. See whether we can get the knobs off. Whether we can lose them. Oh, that was clever. That's gone on the floor, right in the tat. Wow, managed to rescue that. I'll be never seen again. I seem to remember that one can be difficult. You have to remember I've got exceptionally strong fingers, helped by being a church organist and playing solely mechanical pipe organs, not power assisted ones. When I look at these ones in America with about 6 keyboards, they're all power assisted. There we go. So I'll pause the video at that, and I will go and put all these bits in the dishwasher. Right, and we're back with you after that, and all the things are in the dishwasher. So we're going to power this up, but not off its main supply. In fact, I think we'll just undo the plug right now. Obviously it's going to get a new one because half of it's missing anyway. Somebody's even pinched the fuse. That's probably why the lid's off, because somebody's pinched the fuse out of it. Oh, where can we get a fuse from? So what I aim to do in this video is to service the radio and do the 3D printed meter in the one video, and then we'll look at the power supply and the ripple on the power supply as best we can as a before and after, as requested by a viewer. I think we'll just do this SO239. I mean, all these were in a storage shed, a big metal shed at the farm where they keep tractors and things. So we'll run wherever the fiberglass brush has gone. Come on, fiberglass brush, where have you gone? mean, that tells me that I think they've had water come down the coax, because it does happen. Right, we'll get this connected to our test equipment. We need to disconnect the power supply here. Helps if I turn this soldering iron on, so it's not waste time. We'll get that connected. These don't have an extension speaker socket. We'll need to find a microphone wired for this type of radio. It's a little dinky one it came with it being originally a transportable and then re-put in a big box. You got the same dinky microphone. Right, let's get the wiring unsoldered from the internal power supply. Just like that. And the first thing we're just going to do, I'm just going to change this capacitor. I think it is there. They're glued in as well, just to make things harder. So negative is shown with the shading in this case. So it's 1000 at 25 volt. I'll just check that's what we put in. We upgrade this to, I think actually we upgrade this to 2200 and this to 2200. I'll just have to go and look at my notes. Right, so we'll change this capacitor to the 1000 microfarad one. And then we'll get it powered up. Especially when the soldering iron warms back up again. Just wondering what that is there. It looks a bit dry joint, and that looks very, very dry joint. Can't say these are a set that suffer from dry joints, but it depends what the environment is. What's happened there? Something being changed? Right. So we've disconnected the internal power supply, as you've seen, and so we'll now run it on our crocodile clip. They'll probably short out, but then what's new there? Okay, so I need to look at the front, see what switch is which. Power. Here we are lit up and it's on channel 8. There we go. There's channel 20. That's just a dirty channel selector switch which will self-clean with use. Right, I don't think you need didn't think you need a mic for these to receive. But on the other hand, I'm not hearing anything. Go and find a Murphy mic. Maybe a lot wrong with this, we don't know. I'm actually plugged into the wrong, that's the roof aerial I'm plugged into. And that is the test equipment. Switch to transmit, the 3-watt scale. We must be on low power. There we go. Right, let's start making some notes. So it's the X Farm 1000 microfarad 25 volts. I think it's a nice today, I really don't care. Worry about the serial number later. So the meter is moving a bit, but nowhere near where it should be. So let's see what the real power is. It's 3.1. Let's go to channel 40. It's 3.2. And let's go to channel 1. Oh, 2.7. Not the normal way around. There we go. So we'll see what the current constant is, 977 milliamps, which is about right for that kind of power output. Let's go to low power, and it is 250 milliwatts. Okay. Let's look at deviation. For what it's worth on this test set. Wallow. It's 1.5. I'll switch the test set on so it can be warming up. We don't have a VCO method, so let's have a look at the frequency. We'll go to camera 2 on here and we'll key up, and we should have 27 79125. We have 27 79110, that's fine. We'll pull it up a bit if need be. RF meter low. Does the SWR meter actually work? It does, yes. We'll take that meter out and put that in another set. No meter lamp. No public address. The only sockets it's got work. All the switches work. I'll put a note though, channel switch dirty on display contacts. You shouldn't have to do anything about that, it should just come right. Right, okay, we've got no receive, no audio at all. So if I put our extension speaker kind of, can I get that across the terminals, or shall we'll use the crocodile clips? I want to do it to the extension speaker on the wall rather than the test instruments at this stage, just in case there's it could just be the speaker that's stuff, you know, they might have had it very loud, which will be fun because that'll be expensive to replace. That's probably why they stopped using CB. I will also add that this farm batch came with an illegal linear amplifier, which will be dismantled. So the fact this was doing 3.1 watts wasn't necessarily what they were doing. There we go, there's receive. The speaker's open circuit. Remember the eBay thing said all came out working. Yeah, right. So we'll put the frequency in the signal generator. 277911. Oh, it was 79. Right, that's on frequency for that, how the set is. Guys, it's deaf as a post, folks. Ah, RF gain control is so iffy. That's better. Right. I'll turn off the power supply. How do we get to the controls on this? Well, that's a bunch of giggles, isn't it? What a laugh. I think we've got to disconnect the front from the main chassis. And they're a type that aren't necessarily able to be cleaned. So what I'm hoping is to be able to part that enough to get to this side, to get to the controls to clean them, but they're not the nicer type. Might have to take these off individually and see whether they can be cleaned from the top side. That's squelch. Tell you what, we'll do the RF gain ones are the most bothersome. We used to have spanners that fitted these, you know, box spanners, back in the days when we did British black and white television sets from the 1960s. But these are all kinds of different types. So all will be revealed if it's the type that can be cleaned at all. I don't have to order replacements and wait for them to arrive. So poke that through. Yes, so this type we've got to take them out individually and put the service cell switch cleaner through the top. Some of the Cybernet sets use these type, which is frustrating. So I'll do it a second time, because I don't want to have to be dismantling it and dismantling it and dismantling it. Then all we've got to do is get it back in the right way around. So behind the scenes, I'll do that with the rest of them. Why isn't it going back in its notch? There it is. This is before we've even started. Okay, well, we're going to have to change that control. I've had to saw it off because the shaft jammed, and so I've ended up having to actually cut it out. Now this scrap Harvard Good Buddy has the same type. They're quite squat, these controls, in comparison to others, so hopefully these are exactly the same type, the awful ones in other words, and hopefully one of these is 10k as well. So let's just take the first one off at random. I used this type of pad saw with the limited amount of, I couldn't use an ordinary hacksaw. Right, let's see what this says. I'll just cut it off the wiring for now. $100k, that won't help me. Right, that will be the RF gain on this set, so let's see what we've got here. Because you're going to expect them to be a bit oddball, with it being a bit of an oddball set. So this would be the squelch control on this set, and it is 10k, just what we want. So take the wires off this one. Right, so where we are, I'll just re-tin those, and we'll take the precaution of cleaning it as we were doing with the original one, because these are just as lousy. See, normally you can put switch cleaner in through holes. There's a hole there, and there's a hole in the top, so that's where we'll apply it. Hopefully that works. All we've got to do, he says, is wire it back up. And that's the remains of the tag. And it was the brown wire to the centre. Anyway, you don't want me to watch me do this all day, so I'll pause the video. Right, we're reconnected back front panel wise. I've taken all those 4 off. We've replaced the RF gain one, and the other ones, the other 3, have been taken off and cleaned, and they didn't break. So let's power this back up. RF gain now working properly. There you are, what can be had off a Harvard good buddy. We had the display, didn't we, for a realistic 1004 emergency radio off the same set the other day. Have I got any notes on this chassis? I usually throw them away. This is the transportable version, the same thing as I've showed you. So let's do the transmitter. I certainly want to get the deviation done. We're now well into the evening, and I've gone beyond what I wanted to do, because that's taken more time than you might think. So looking at that, let's go into transmit. We're on channel 20. Let's go into, let's see where the frequency is now. 79118. Shall we do that? Yeah. Where is it? It's a coil on these, and it's there. Needs to go down to bring the frequency up, right? Just take it to 26, so it's just slightly high. Right. Replace RF gain potentiometer, second hand, clean all others. I think this is the farm environment's got to this one. Right, power, transmit power starts here. So we'll key it up. I'm going to show you the right meter. We'll go from the 3 watt scale to the 30 watt scale, so 5 watts is there, 4 watts is there. So we're about 3.2. Which is the centre of the peak. That wasn't quite there, so that's improved. Oh, that was well out. We're now at 3.4 watts. That was slightly out. We're now at 3.45. So we'll get the Velleman kit out, the ones that Gareth did for us. I think we want the green one for this. So this is the pretend green one. No, that's the pretend white one. Where have I put the pretend green one? I don't know. We'll have to use the real green one. No, it isn't the green one. Perhaps it's the blue one. Try the real blue one. I think it is, but we'll use the stronger one that Gareth made. There we go, key up, and oh my goodness, I brought it up to 5 watts. That one, looks like they want you to tune it on this one. So we're now at exactly 4 watts. Let's change channel. Channel 1, 4.05, channel 40, 3.95. I think that is jolly good. So 4 watts. Oh, what did I say? It's the right way round. 3.95 and 4.05. So our current consumption, let's go back to channel 20. Has dropped to 998 milliamps. Well, it hasn't dropped, has it? It's gone up 200 milliamps. It's gone up 20 milliamps to give nearly a watt more, certainly 900 milliwatts. So it just goes to show that was off tune. Let's do low power. Let's switch on low power. I don't know if it's adjustable on this, I can't remember. At the moment it's 280 milliwatts. I don't think it is adjustable. Let's put that down then. 280 milliwatts. And what I do want to do is the deviation. I'm going to do that right now. We'll just have another look on here as to what it says. Wow, it says 1.2 or something like that. So go over to the deviation meter on the test set behind me. And wow, oh, it's loud, it's 1.5. Deviation is this one. Wow, that's not right. Wow, no, there's something wrong with the set. Now we've had this before, haven't we? Now there isn't time to do that today, so we've got low TX audio. Tell you exactly what it says. Wow, it's about 1.8 on full whack. Now these don't work like that. There's usually plenty of audio, so we're going to have to sort out. There's likely to be some failing capacitor, so we'll have a look at the transmitter's audio preamp and get that sorted. That'll have to be on tomorrow's video. I've got a circuit here, so microphone preamp. Yes, so we have the 4558 chip, but I don't think that's faulty in this occasion because it was on the one we did, I think the last one we did actually, because we have got nearly enough audio. And you could say, oh well, it's good enough, but I know these sets don't have an inadequate transmitted audio. So what we'll do, we'll blanket change all the capacitors in that part of the circuit, and I'll do that tomorrow. So we've got transmits now fine. It probably sounds alright into my walkie-talkie. Let's put my walkie-talkie on if I can find it under my bits of this set.
Testing 1 2, testing 1 2 3 4 5 5 4 3 2 1.
You say, yeah, that would be fine, but it isn't, because that's at full whack and it shouldn't be like that. Right, so we'll do those. So now we'll move on to the receiver. It can be quite tricky to align. Let's put the cyanide meter on, and we'll go from our speaker, which is mounted on the wall, to the test instrument speaker. Could be the wrong way round. Yeah. In fact, we're going to have to replace the speaker on this. It's going to be a substantial cost. Okay, and the meter is working, but I say we'll recover that and put that in another of my sets where the meter isn't. So, receive. Here we go. So we can jot down the figures for a start. Now we're connected up. Make sure we're on frequency 79125, because we've now corrected that. There we go. And let's go over to the cyanide meter and take some figures down. Making sure RF gain's at full, which it is. Squelch is at minimum. Well, we've actually got 20 dB showing. It's between scales. I've got 1 microvolt on one scale and 1.1 microvolt on the other scale. So we'll go with the worst, which is 1.1. And that's absolutely fine. For 12 dB, we've got 0.53, which is also fine. And for 10 dB, I tell you what, this is a flawed test at the moment because you've got this delta tune thing. As it happens, it was in the peak position. And for our 10 dB, we've got 1.4. Oh, I'm on the wrong scale. 0.45. Squelch to full. And let's go and look at the attenuator. Oh, that's lousy. Full squelch is 2.8 microvolts. That wouldn't squelch out the skin off a rice pudding. Set threshold on the radio. Signal generator back on. 0.41 is excellent. Hopefully that's adjustable. We're not putting, I mean that's reading right. Not interested because we're going to replace the meter as part of this demonstration. US. So it's 1.5 and there's a fault. So let's do the transmitter, the receiver then. So we'll go over to our oscilloscope and we'll remember to switch it on. Put 100 microvolts on the signal generator, so we'll have an S9 equivalent signal, and we'll adjust the detector, which is what? Do my notes tell me? It's going to be that one there. That was absolutely spot on. So that's a good start. I think the only saving grace that this meter still works is that the meter lamps failed and they haven't replaced it. It's when they get bigger bulbs in, because they're not well illuminated. People put bigger bulbs in, it melts the mechanism. They were never intended to be backlit. So these meters were £1.95 from Maplin's at the time. You know, they were a really cheap meter for a double meter. So you can't expect them to be lasting even like the cheapo meters on Cybernet and Uniden sets. I think we'll do the IF first. Show you the... No, we'll show you the Synad meter. So I'm just about 18 dB. I want to be moving that needle to the left. Oh, got the squelch on. And that's my peak. And the same on the next one. He's there. Let's turn the signal down a little bit. About these two. That one was absolutely spot on. And now we've got the front end to do. Use a 1.5 tool and go to a lower signal. It's interesting, the front end is spot on, and all but one of these was slightly out. Detector was right, but 3 of the 4 IFs were out. So hopefully we've got a better figure. I'd hate to have fixed it worse. So let's look at our 20. Yes. It's showing us 0.9 on this scale, so we'll go back to the normal scale. And it's showing 0.93. So again, we'll give it the worst figure. This is where your range is improved, it's not transmit power, it's receive. 0.93. 12 dB is 0.47. 10 dB, 0.43. So the clarity's improved. Let's see if we turn down the signal generator further. Let's see where we can hear it down to. Not looking at figures, but what we can hear it down to. So there's 0.3. Let's put the other tone on instead. And I will turn down the attenuator, 0.3, 0.25, 0.2, 0.15. I can hear that down to 0.11. Let's put the other tone back on. I can hear the other tone about 1.6. So, you know, it's got the sensitivity very much so. So we need to deal with this squelch because it's, I think the phrase is crap. Squelch to full. Yep, it's still lousy. So, what do we want to do? We need to find where it is. And I haven't got a note on here. Just like you'd expect me not to have. You'd expect it to be around there because... No, you wouldn't. You'd expect it to be around the... you'd expect it to be that one. That is either the meter, receive meter, or it's squelch. because your FM chip's there. I'm looking at the meter, and it's the meter. So we're looking for another preset in the same area. That's another preset in the same area. Let's put the signal generator up. That's the squelch, all right. Right, it's a bit, trying to get that to average out. It's a bit stronger than I would like. It is, on maximum, it is 100, 300, it's 650. 650 microvolts. And on minimum squelch, .32. So that's manipulated that really nicely. That was the best compromise. So we're done on that. So we've done the set. It's now, apart from the transmitted audio, which anybody would think is okay, but I know isn't. We'll take this meter out. There's just a sticky pad on this. Let's turn the radio off as well. Okay, so our SWR one is that one. So we're going to remove that. And we will just cut that bit off. And unlike people who ruin Cybernet sets, I'm going to put a piece of tape over the end. And not chop the wire off and just tuck it in. So the other wire, we've got, in fact we've got the meter lamp. What I'll do with that, I'll keep that with this meter. I need to unsolder the red wire, which is our S meter, and I will unsolder our black wire, which is our earth. I'm going to cut it off. I don't want to damage the meter with heat. And then I'll chop the wires to the lamp. So now we've recovered that meter, which is a working meter. So, isn't it typical that a set as lousy as this and the meter still works? So, the next question, take away paperwork for a bit. And we'll get Gareth's bag of tricks. our meter. This came off a brand new illegal AM set. So that is a new old stock meter because it was new in a box radio that I chopped up for parts. So, all we need to do, hopefully, is wire this up. Not sure how to do the meter lamp on this. What I do know is we've got some very short wires that might be enough. And hopefully our new old stock meter lamp works on our new old stock meter after 40 odd years. I'll tell you what, I'll get this soldered up and then we'll come back to the video. Okay, so that's the meter in. Let's power it up. That I think is too bright, so I think we're going to be fiddling with the ballast resistor on that. So let's see whether we can actually get it to calibrate. So let's key up. Got nothing. We got receive. It's backwards. Now that's interesting. I put the red wire to the positive and the black wire to the negative. So clearly they're the wrong way around. Right, we'll try again. I've added some ohms to the ballast resistor. I still think we want more. I mean, that's a bit of an experiment, isn't it, to see what we want. So let us put the light back in. So what we're on, low power? We're on low power. That's high power. And we want to calibrate that for 4 watts. Adjustments at the back. There we go, 4 watts. It's a dummy load. Let's see what it says on low power. It says there. Right, on receive. Want 100 microvolts on the test set. That's 100 microvolts, making sure RF gain's at full. And it was the preset there. For S9. So there we go. I'm going to plug the aerial in just for giggles. Let's see if anybody is audible. One on a Roger. Okay, nobody on. Seems to be a lot of interference on there, but nevertheless, all we need to do is Want to make that ballast resistor even stronger resistance to reduce that meter brightness. We want to sort out I think there's 3 capacitors we'll just blanket change, and sort the power supply out and do a bit of a demonstration for the ripple. So there we go, that's kind of part 1 of getting the Murphy base station into something like. Thanks for watching.